Usually for kinematics question, I will start off by drawing a graph first to have a graphical representation of what is going on. Okay, so the car starts from rest, so you know that it will start from the origin, and it accelerates constantly for 3 seconds. So the fact that the acceleration is constant means that the gradient of the velocity time graph is a straight line, is constant. Let's just label the graph here. This is 33 meters per second. Okay, so essentially the question is asking you to find the gradient of the velocity time graph. The gradient of a velocity time graph will give you the acceleration. Okay, so for this case, acceleration is simply change in velocity over the time taken it takes to have that change in velocity. So this is equals to 33.0 meters per second over 3 seconds. So this is just 11 meters per second square. This should be quite easy for most of you. Question 2. This question is asking you to find the final velocity given a certain acceleration. Again, I will draw the kinematics graph first. This is meter per second. The x-axis is time. The rocket starts from rest, so again you know that the graph will start from origin and accelerate at a uniform rate. So the velocity time graph is a straight line graph. It accelerates for 2.4 seconds. So you can draw a straight line for 2.4 seconds to reach a velocity of something, which is what the question is asking you to find. But for this case, we know that the gradient, which is the acceleration, this is 190 meters per second square as given in the question. Okay, so how do you find velocity, find VF, the final velocity? So a simple equation to use is VF equals to the initial velocity plus the change in velocity. Okay, the initial velocity is 0 meters per second plus the change in velocity is simply the acceleration times the amount of time during which this acceleration takes place. Okay, so this is simply 0 plus 190 times 2.4 seconds. If you punch this into the calculator, you'll get 456 meters per second. So the final velocity is 456 meters per second. Okay, question 3. Question 3 is very similar to question 2. It has a constant acceleration as well, but for this case, the car has an initial velocity of 15 meters per second. So this is a bit different from the previous two questions that we have seen. Again, I will draw the kinematics graph. So because the car has an initial velocity of 15 meters per second, the graph wouldn't start from the origin. So you'll start somewhere around here. So let's say this is 15 meters per second. And then it accelerates at a uniform rate for 6 seconds. So you go up a straight line because the acceleration is constant. Okay, accelerates for 6 seconds. This is the final velocity, which we wouldn't know, and we are supposed to find out. The gradient of this graph is the acceleration, which is given in the question, and it is 3.2 meters per second square. Okay, so the question is, what distance does the car cover during this time? So to find the distance that the car covered during this time, we are basically finding the area under velocity time graph. Okay, the area under a velocity time graph gives you the distance covered during that time frame. Okay, I've shaded the area in red. So how do you find the area under the graph? Find the area under the graph, we use this formula, half times base times sum of parallel sides. Parallel sides. Okay, so this is basically half times 6 seconds times sum of parallel sides, which is 15 plus VF. So this is the base. I'm going to highlight in yellow. This is the base, which is 6 seconds over here, and this is the parallel sides, which I'm going to highlight in green. Right now our job is to find what is VF, because we don't have the value of VF, right? Okay, this part is very similar to question 2, where VF is just initial velocity plus the change in velocity due to the acceleration. So the initial velocity is 15 meters per second plus acceleration times the time during which the acceleration takes place. So this is 15 plus 3.2 times 6 seconds. If you punch this into the calculator, you will get 4.2 meter per second. Okay, so just put this number into the previous equation. Distance traveled equals to area under graph, which is equals to half times 6 times 15 plus 34.2. Answer is 147.6 meters. So this is the answer. Question 4. To answer question 4, you have to be very clear of the differences between displacement and distance. Distance is a scalar quantity, whereas displacement is a vector quantity which takes into account direction. At the end of the round trip, the person would be back at where he first started. And as displacement is a vector measurement of distance between the final and initial positions, the person being back at its starting position has zero displacement. If the starting position of the person is here, if it goes one round and take weird routes, but if it comes back to the initial position, the displacement of that person is zero because there's essentially no distance between the final position that he is in and the initial position where he first started. Let's take an example where displacement is non-zero. So again, if this is the initial position, he travels some route and ends up here. Displacement of the person would be this distance and in this particular direction. The route that I'm highlighting in green, this is the distance that he traveled, but this is the displacement, the part that I'm highlighting in yellow. Question 5. Alex drove 300 meters west along PIE, 300 meters west, and then 400 meters north along CTE. So this is 400 meters. Part A of the question asks you to find the distance traveled. The path that I'm highlighting in yellow is the distance traveled by Alex, the actual route that he took. So distance traveled is equals to 300 plus 400 meters equals to 700 meters. So this is the distance that Alex traveled. Part B. Determine the magnitude of his displacement. I'm going to draw his displacement in red. So we see here, this is the initial point, and the final position is here. The displacement is this distance and in that direction. I'm going to highlight this in green. So to find the displacement, as I've highlighted in green, we have to use Pythagoras theorem because I traveled west first, right, and then north, so we know that this triangle is actually a right-angled triangle. Displacement simply the square root of 300 square plus 400 square, which is 500 meters.